All right, we're continuing on with our solving of polynomial equations. So we're going to determine the number and the types of each of our polynomial equations. And then we're going to find some zeros for polynomial functions or equations. Now, I need to do some definitions for you. Next slide is going to look like a lot of mess, but there just needs to be some understanding of just some differences in terms of the terminology that we're using. So let me kind of go through this with you. So we have a polynomial function, a to the n, x to the n, so on and so forth. C is considered a zero if, when we do the remainder, we get 0. So if c is the 0, then x minus c is considered a factor. So the 0 is there, the root, 0 and root or solution are all pretty much coincide. X minus c is what's called a factor. And because c is a 0 or a root or a solution, we will have an x-intercept on the graph, so c comma 0. So if the answer is 4 or the solution is 4, we know it's a solution because the value equals 0. The factor would be x minus 4, and that's what goes in parentheses. But we are going to try to find the solution is what we are trying to do here. So just so that you understand. So if I'm graphing this, and this is a W-shaped, it's degree of 4. It crosses the x-axis at -2, -3, 1, and 2. This formula here has 4 zeros, -3, -2, 1, 2. It also has 4 roots, the same one. Now the factors are when we go ahead and we flip them around. So x plus 3, x plus 2, x minus 1, and x minus 2. If we multiplied all 4 of the factors together, we will get this equation. If we Punnett squared all of this, we would get this equation. And because these are all zeros, I could write the ordered pairs as -3, 0, -2, 0, 1, 0, 2, 0. That is just so that you understand the definition between these different things. They're all related, they all come from the same place, but it goes ahead and works when you go ahead. The zeros are part of the equation, the graph. The roots or solutions is when we set it equal to 0. The factor is what we go ahead and multiply together to get this, and the x-intercept is along with the zeros where it crosses the x-axis. So those are the different things. So how am I going to use all of this information? So I kind of told you that we're talking about the fundamental theorem of algebra. Now the fundamental theorem of algebra is a little more in depth than what you're seeing here on the screen. That's why it's called a corollary to the fundamental theorem. But basically what we're saying is whatever the degree is, that's how many solutions or roots that we're going to go ahead and have. Now understand that they're not always going to be real roots. They're not always going to be numbers. Sometimes they'll be square roots, and sometimes it's even complex numbers, like i's. But they will have that many roots. So a third degree polynomial will have 3 roots. A fourth degree will have 4. A fifth degree will have 5. And we're going to be looking to solve for all of these. So whatever the highest degree is, that's how many answers we should end up getting. All right. So if I'm looking at this problem right here, it's a 2, so I know that I should be able to get 2 answers. Now, we've done a problem like this. We can go ahead and factor it. 2 numbers that multiply to 48 that add up to be 2 is 8 and -6. And we get our 2 different answers, and you can see that there's 2 real roots. Now remember, with quadratics, we could also get imaginary numbers with our i's if we had a negative value and stuff like that. So just understand that that's what it has to be. This is a 2, so we're going to have 2 answers. All right. Yesterday we went ahead and gave you an answer to go ahead and start this process off. Now we're going to talk about how we go ahead and find our own answers, because they're not always going to be given to us. And one of the ways that we do that is by using Descartes' rule. Now, this again may not necessarily seem like it's the easiest or the best way of doing it, but it will help us out. So the number of positive zeros is the same as the number of changes in the sign of the coefficients. Remember, the coefficients are the number parts. So if I'm going to put a 1 in here, I'm going to do p of 1. the number of changes are going to be how many sign changes we have. And then I'm going to go ahead and do the same thing, but for the negative, I'm going to put in -1 or negative x. And let me show you this with an example. All right, so here's a polynomial. And so I'm going to go ahead, and it has degree of 6, so we will have 6 zeros of varying different types. They could be real, they could be positive, they could be negative, whatever. All right, let's figure out how many are positive and how many are negative. So to do this, I'm going to put in p of 1. Well, if I put 1 in here, I get -1, and then 4, and then -2, -1, and -1. Now what I'm going to look for is I'm going to look for sign changes. From -1 to 4 is a sign change. Yes, we go from negative to positive. Here, also another one. But here we have 2 negatives, so that's a no. And 2 negatives again, no. So I have 2 sign changes, 2 yeses. That means I have 2 positive zeros. Now I could also have that -2. So I could have 2 or 0 positive numbers. All right. So 2 sign changes, so there are 2 or 0 positive. Now the reason why we always subtract 2 is because things come in pairs. If you remember our quadratic formula, it's always that plus or minus, and so it always comes in pairs. All right, now let's try the negative ones. So we're going to try negative x here. So I'm going to put a -1 in for all of these. -1 to the 6th power doesn't change anything. The only ones that are going to change are all the odd powers. So this one's not going to change. It's still going to be that -1. This is an odd integer, so it changes to -4. This one's just -2. This one's going to change to +1 and -1. So if you look at our problem here, the ones that changed was this 3rd power and the single power here. So the 4 became negative and this one became +1. That's the only things that change. The even powers stay the same. So -1, -4, and then we're looking for these sign changes again. Negative to negative, nope. Negative to negative, nope. Negative to positive, yes. Positive to negative, yes. So we have 2 yeses again. So that means that we're going to have 2 or 0. All right. So we can have 2 or 0, and then 2 or 0 negative. And so these are a bunch of different combinations. If I have 2 positive and 2 negative, that means I'm left with 2 imaginary to get to my total of 6. I have 0 and 2, 4 and 6, 2 and 0, so on. These are all the different possibilities that I can go ahead and have. And remember, these imaginary ones are just I values. Again, they come up in pairs. All right, so let's talk about this one. How many does this one have? Sorry, having problems here. There we go. So here's the thing. We have 1, a +1, -1, +1, +1, 3. There's a change there, 1, a change there, 2. So we have 2 possible positives. So I could have 2 or 0 positive answers. Now, doing -1 in here, the 4th power doesn't change. The 3 does. The 2nd doesn't. That one does, and that one stays the same, obviously. So now I look at changes here. I have a change here and a change here, so 2 or 0. So then for my imaginary, I have 4 possible, so it's 4, 2, or 0. Always subtract 2. All right, so how does this help us? So this goes ahead and helps us to know where to look for our zeros. Are we going to look on the positive side, or are we going to look on the negative side? All right, so let's go ahead and look at our sign changes. So starting with 1, that's a 1, a -1, a 2, and a 4. So now I'm looking for my changes. There's 1 there, and no. So that means I have 2 different changes positively. What about negatively? The 3 changes sign, so that becomes that one. This one changes sign also. Those 2 stay the same. So no change there, no change, yes, a change. So this -1 here has a change. So we have 1 negative and either 2 or 0 positive. So what does that mean? Because we have a degree of 3, we're going to have 3 possible answers. So we can either have 2 positive and 1 negative, or 2 imaginary and 1 negative. Either way, we're going to have a negative. So that's where I'm going to actually start focusing in on. All right, so we go ahead and do our synthetic division. Now we went ahead and did this in a little chart here, but just understand how this goes. This is my original. This is technically 0. So my value here is 4. So at 0, the polynomial is at 4. So now I need to try a value. I'm going to try some negatives because I know there's going to be a negative root somewhere. There's either 2 or 0 positive. So if I start looking at positive numbers, I may find one, I may not. So I'm not going on a wild goose chase. I'm going to start with the one that I know that is negative. So I go to -3. So if I put -3 in here, I drop my 1. 1 times -3 is -3. Add it and got -4. Notice I'm just kind of missing that middle part of my synthetic division. -4 times -4 is 12, plus 2 is 14. Multiply and we get -38. That's obviously not a 0. But notice something, please. 4 to -38, there has to be a 0 somewhere in between this spot, between 4 and -38. So between 0 and -3, there has to be a solution because it crosses over. We talked about that last week, that if the value goes from a positive to a negative or a negative to a positive, there has to be a 0 somewhere in there. So it's between 0 and -3. So try another number. We tried -2. Bring down the 1. -2 is -3. 6 is 8. -16 is -12. So I know it's not between these two because those are both negative. So now it's between 0 and -2. Well, let's try -1. And we do that, and we get 0 as an answer. So I have 1, -2, and 4. So I have my one solution here at -1. Now I'm left with a quadratic. I want to factor this. 2 numbers that multiply to 4, that adds up to be -2. Unfortunately, there aren't any. And because of that, the only option that I'm left with is the quadratic formula. So I have one solution at -1, and then I'm going to use the quadratic formula to find another solution. So how do we do that again? Remember, that's that b squared minus 4ac, -b plus or minus all of that divided by 2a. We start with this part in here. So b squared here is 4, and then 4 times 1 times 4 is 16. They replaced all of it. Again, we tended to just leave this off to the side for a little bit. So we go ahead and do this, and we get -12, simplifying. -12, we have to birthday cake. -12 is 2i root 3. It's 2 times 2 times 3, so the 2's come out. And the -1 means it's an I. So we rewrite it as 2 plus or minus 2i root 3 over 2. And then remember the 2's we have to go ahead and cancel out also. So it's 1 plus or minus I root 3. Now understand that this is 2 answers, 1 plus and 1 minus. So that's 2 answers plus the original one that we got at -1. So we have our 3 answers for this problem. And if you're looking at this graph, notice how it crosses here, and it never really comes back down and crosses again. There were no positive. If I started looking over here for positive ones, I never would have found one because there isn't any. It's 1 negative and then 2 imaginary. All right, let's try another one. All right, so there's going to be 3 answers here. And you notice my answers down here, 1 and 1 plus or minus the square root of 5. I got 3 answers. So I'm going to start with this sign change stuff again. So I'm just taking the coefficients for when I put in 1. So it's +1, -3, -2, 4. That's 1 sign change there and 1 at the end, so 2 total. And then I'm going to do the -1. So this switches and this switches. The other ones stay the same. That only gives me 1 change. So again, I know there's a negative, maybe 2 positive, maybe 2 imaginary. I don't know. So let's start with this negative idea. So here's my table. I go ahead and start off. The first one is 0, 1, -3, -2, 4. So I have a value that's starting at 4. So I'm going to try -1. So -1 worked last time, right? So let's try it. So drop the 1, and we go ahead and do it, and I still get 2. So It's not between 0 and -1, so maybe I jump down to -3. Obviously, that's probably a little bit too far, you say, but okay, I'm just kind of doing it for so you can see. So -3, and I do this and I get my -44. Well, now I know that there's a solution here between 2 and -44. Okay, so what's between -1 and -3? Well, -2, right? So now I'm going to try that one. I get -12. Now I start to have some issues. This -44 and this -12, well, now I'm in between -1 and -2. I got no numbers between -1 and -2. So I know that that one's going to be some sort of a square root. I'm not going to be able to find that. So now I got to go the opposite way. I got to go ahead and try to see if there's a positive one I can find. I don't know if there is. There could not be. There has to be if I have a square root, because remember, square roots come in pairs. So it's got to have another pair. So if I have a negative square root 1 in here, there's going to be a positive square root 1, which means that there's a positive answer, which means I got to have another positive answer in there. Okay, so this is okay that I found this. I got to switch back to positive now. So I tried 2, just trying to get a little bit down, seeing where my numbers are, right? So I try 2 and I get -4. Well, now I have 4 at 0 and -4 at 2. Well, it crosses somewhere in the middle there, so I try 1, and 1 goes ahead and works. So there's my first answer. My first answer is 1. Now I got to find my other ones. Again, nothing multiplies to -4. That adds up to be -2. So I got to try my quadratic formula. So b squared is +4 minus 4 times a times c. Simplify that as 20. Go over here. I got to go and do birthday cake for 20. 20 is 2, and 2 is 5, and 5 is 1 with the cake. So that's 2 root 5. The 2's come out root 5. These all cancel, the 2's, so I get 1 plus or minus the square root of 5. And that's what my answer is. All right, let's try another one. This one is degree 4. So I'm going to have 4 answers on this one. All right, doing my sign changes. 1 is, again, not going to change anything. So it's 1, -3, -5, 3, and 4. That has 2 changes. So I have either 2 or 0 of them. If I try -1, that's 1, 3. These odd degrees change. So that one changes and this one changes. Notice the difference. All the other ones are the same. So the odd degrees change. And that's 2 changes. So I don't know where, normally we would like to have an odd number in there because that kind of keys you in that there's something going on there. But it is what it is. So I got to just start somewhere. So again, I started with 2. 2 sounded good, so I went ahead and I put in 1 and kept going. I got -18. Well, 4 to -18, there's got to be a 0 in there. Well, now I kind of focused in, and I know that 1, I'm going to try 1, which is in the middle between 0 and 2, right? So I try that, and I do get my 0. So I have a 1 as an answer. So now I want to go ahead and use the answer that I just got. Notice I do not go back up to the top. I could, but it's just going to cause me all kinds of problems. This is going to allow me to keep simplifying. So I'm going to try another number. If I have 1 positive answer, I should have another one, right? Because it's 2 changes. So there should be a second one. So I got to go look for it. So I try 3. I get -16. Well, that's not a 0 there. Let me try 4. Well, that's a 0. And I'm left with 1, 2, and 1. Now this one does factor. 2 numbers that multiply to 1 that add up to be 2. Well, that's 1 and 1. So those answers are -1 and -1. That's what's called a double root. It is possible. There are technically 2 answers. So it's 1, 4, -1, and -1. You can write it this way with the double root. All right. Let's look at how this graph looks, just so you understand what's going on, especially with this double root. So when I look at this graph, 1, 4, and -1, right? So there's the 1, there's the 4, and notice how the graph just kind of keeps going. It is a even graph. So because it's even, we know the end is the same, so they're both going up. Now look at what happens here at the 1. It comes down and just touches and goes back up. This is called a double root because it goes ahead and the minimum is right there on that x-axis. And because the minimum's there, that means that is actually 2 answers because it doesn't go down and come back up. It doesn't have the 2 sides. It just has that 1 spot right there. And that can happen. And that's where you get this double answer of -1. You have -1 actually twice. So if you're looking at your graph and it kind of does that, be careful because you know that number should actually be 2 separate answers in here. We got -1 twice. I could have synthetic divided here with -1. I would have needed to do it again to go ahead and get my second set of answers here. So just be careful of that. All right, last thing, we should be able to work backwards. If we have an answer, we should also be able to go back and get the polynomial. And what this is just saying, this complex conjugate theorem, is if I have a plus, I also have to have a minus. Again, they come in pairs. All right, so how do I use this? Write a polynomial with a degree that has these zeros. So it has 4 and 4 minus I. Well, what that last formula said is I actually then have to have another one. This 4 minus I also has to have a 4 plus I. So 4 plus I also has to be a 0. So then I go ahead and solve each of these. So it's x minus 4, and then x minus this, and x minus that. That's what it means to be a factor. We're just moving them back across. So I have these things, and basically what's going to happen now is I'm going to need to multiply this all together. Just doing different Punnett squares. I suggest Punnett squaring these two together, even though it's going to be a 3 by 3 Punnett square. You're going to all these i's will end up canceling each other out, and actually it will be pretty easy to go ahead and do that. So if we multiply this all together, this over here actually simplifies pretty easy. Notice how they went ahead and replaced all of that. You got x squared minus 8x plus 17. And then you just got one more Punnett square to do, a 2 by 3 here. And you get these different values, add them together for my final answer. And that will have all 3 of those as solutions. So you should be able to work backwards and get this. That's what I have for you today. Long day, sorry.